Welcome to Spaceverse, your portal to cosmic adventures. Dr. Melgon and his team have made an exciting breakthrough using the Spitzer Space Telescope. It turns out there are 7 Earth-sized planets orbiting the nearby TRAPPIST-1 star a mere 40 light-years away. Today, we're diving into one of the most buzzed-about discoveries of the year, the TRAPPIST-1 system and its 7 mysterious exoplanets. And guess what? We've got a very special guest to help us explore all the exciting details. The TRAPPIST-1 system has been blowing minds ever since its discovery in 2017, with its unique lineup of 7 rocky planets. Located just 40 light-years from Earth, it's one of the most promising spots for studying planets that could potentially support life. Thanks to the James Webb Space Telescope, we're learning more than ever about these planets, from their atmospheres to their geological activity. And trust us, there's still so much we don't know yet. In this episode, we'll take you on a journey through the TRAPPIST-1 system, uncovering what makes these planets so special, how scientists are studying them, and what these discoveries mean for our search for life beyond Earth. You won't want to miss it. TRAPPIST-1 is a red dwarf star, also called an M-type star, which makes up about 75% of all stars in our Milky Way galaxy. These stars are smaller, cooler, and live much longer than our Sun, which is a G-type star. However, red dwarfs have some unique quirks, like frequent stellar flares and intense activity when they're young, which raises some interesting questions about whether planets orbiting them could support life. The 7 planets in the TRAPPIST-1 system, from TRAPPIST-1b to TRAPPIST-1h, all orbit much closer to their star than Mercury does to the Sun. But even though they're so close, TRAPPIST-1's dim light means that some of these planets are still in the habitable zone, the sweet spot where liquid water might exist. These planets are also believed to be rocky, much like Earth, making them prime candidates for exploring atmospheres, water, and even signs of life. Studying the TRAPPIST-1 planets, however, comes with its challenges. Red dwarf stars like TRAPPIST-1 have surfaces covered in star spots and often emit bursts of radiation, which makes it tricky to detect the planet's atmospheres. The variability of these stars also makes it hard to tell if signals are coming from the star itself or from the planets. This is especially tricky when analyzing planetary spectra, as the star's activity can mimic the features of an atmosphere. On top of that, red dwarfs go through a phase of intense radiation and luminosity when they're young. This early stage could strip away a planet's atmosphere or make conditions on the surface too harsh for life to thrive. To understand how all of this impacts the planet's potential for habitability, scientists need to use advanced modeling and observational tools. When it comes to studying the atmospheres of the TRAPPIST-1 planets, TRAPPIST-1b and TRAPPIST-1c, the JWST has been a game-changer. Initially, scientists thought these 2 planets were barren, with no atmosphere at all. But as new data has come in, the picture is becoming much more interesting. For TRAPPIST-1b, researchers have been looking at its thermal infrared emissions across multiple wavelengths, like 15 and 12.8 microns. The findings have opened up 2 intriguing possibilities. First, the planet might have a volcanic surface, constantly refreshed by magmatic activity every 1,000 years. This would mean ongoing geological processes and a very young surface. Alternatively, TRAPPIST-1b could have a thick carbon dioxide-rich atmosphere, much like Venus, trapping heat and giving the planet its observed thermal emissions. As for TRAPPIST-1c, early studies suggested it had no atmosphere, but recent data hints at something more promising. This planet could have a thick atmosphere made up of oxygen, or even a steam-filled environment. A runaway greenhouse effect could create a steam world with water vapor that might even play a role in its atmosphere's composition. The idea of volcanic activity on TRAPPIST-1b is especially exciting. If this planet is volcanically active, it could provide the right conditions for an atmosphere to form and even support life in subsurface environments. Plus, such volcanic activity could release gases that future telescopes might be able to detect, bringing us closer to understanding these intriguing worlds. Among the 7 planets in the TRAPPIST-1 system, TRAPPIST-1e stands out as the most promising candidate for habitability. Nestled in the system's habitable zone, this planet has the potential to host liquid water on its surface if it has an atmosphere. A recent study suggests that TRAPPIST-1 might have gone through a fascinating secondary atmospheric formation process, where interactions between hydrogen, oxygen, and iron over millions of years could have produced water and heavier gases. If this planet has managed to retain its atmosphere, it could even have vast oceans, making it a top contender for future exploration. Red dwarf stars, like TRAPPIST-1, are known for their intense and frequent flares that emit powerful UV and X-ray radiation. These flares can strip away planetary atmospheres and make surfaces inhospitable. However, life on Earth has proven to be remarkably resilient to extreme conditions. This has led researchers to wonder if life forms on TRAPPIST-1 planets could also survive these harsh conditions. In a study simulating red dwarf radiation, researchers found that Aspergillus niger, a type of black mold that produces melanin to absorb UV radiation, could thrive if shielded by water or a thin layer of soil. This suggests that life could persist in subsurface environments or oceans on TRAPPIST-1 planets, as long as other conditions are right. One of the biggest challenges to the habitability of TRAPPIST-1 planets is the early life stage of red dwarf stars. For the first few 100 million years, these stars release intense heat and radiation, which could trigger a runaway greenhouse effect on nearby planets. This process might strip away atmospheres, leaving planets barren, much like Venus in our own solar system. To understand if life could still thrive on TRAPPIST-1 planets, researchers are looking at how these planets might recover from this early phase. Models suggest that secondary processes, such as volcanic activity or impacts from comets and asteroids, could replenish atmospheres and create conditions that support life. The TRAPPIST-1 system has also been a hotspot for searches for extraterrestrial intelligence, with researchers using radio telescopes to listen for any signs of alien communication. Over the course of 28 hours, they used a technique called planetary occultation, which involves monitoring for radio signals as one planet passes in front of another. They detected over 2,200 potential signals, but unfortunately, none of them turned out to be artificial in origin. This means that, at least for planets TRAPPIST-1b and TRAPPIST-1c, there's no evidence yet of advanced civilizations using radio waves. However, the search for life, whether microbial or intelligent, continues on the other planets of the system. The TRAPPIST-1 system remains a captivating mystery, with many questions still unanswered about the nature of its planets. Future observations from the James Webb Space Telescope and other advanced telescopes will play a crucial role in determining whether any of these worlds have atmospheres, liquid water, or the right conditions for life. Researchers will focus on several key areas: analyzing the atmospheres of TRAPPIST-1 planets by studying their thermal emissions and spectroscopic data, investigating the geological activity on these planets to understand how volcanoes and tectonic processes shape their surfaces, searching for biosignatures like oxygen or methane that could indicate life, and figuring out how planets might survive or protect themselves from the intense radiation and flares emitted by their host red dwarf star. TRAPPIST-1 is one of the most exciting opportunities for studying exoplanetary habitability and the potential for life beyond our solar system. While some studies have raised concerns about certain planets being barren, others offer new hope for the existence of atmospheres and geological activity. With its diverse planetary environments, TRAPPIST-1 serves as a natural laboratory for exploring how planets evolve under the influence of red dwarf stars. As our ability to observe these distant worlds improves, TRAPPIST-1 will undoubtedly remain a focal point for astrobiology and exoplanetary science. Whether it ends up revealing signs of life or highlighting the challenges of habitability, this star system will continue to expand our understanding of the universe and our place in it. And that's it. Thanks for joining us on this cosmic journey through the TRAPPIST-1 system here on Spaceverse. From the hunt for life to the search for habitable worlds, we've explored the mysteries of this star system and what it could mean for the future of space exploration. Don't forget to subscribe for more thrilling updates on exoplanets, space missions, and the ongoing quest for extraterrestrial life. Until next time, keep looking up.